talk actually just now. My CEO messaged me and told me it should be bringing the fourth industrial revolution to the cloud, and I disagree. I think that kind of philosophy is the philosophy that we have as engineers a lot, which is that there's this interesting abstract problem out there, let's stick it into the cloud. And in reality, what we have to kind of focus on is the fact that we have really interesting tools and we need to bring it to really interesting problems. So who am I? So I'm a senior data engineer. My job is to prepare Oden's data and its pipelines for machine learning and doing proper data science. So originally, when Oden was hiring for this role, they went out to look for a data scientist, and someone who I very much appreciate said, don't hire a data scientist, hire a data engineer, bring in someone to think about your data. I love data engineering ever since I was 14 years old, and I found out I could write bash scripts to organize my music files. I think this is the only job I was ever going to do. And so all I love doing is thinking about the way that data is organized. And so a lot of this talk is me talking about how do we take this big abstract concept, which is manufacturing, and fit it into, or fit the cloud into that abstract model. How do we create that relationship? Who are we? So we're Oden Technologies. We're a startup. We were founded in 2014, and we're pre-Series A. Who are our customers, manufacturers, and people who are making things. So these are factories, these are multi-factory companies, these are focus teams that work within a factory. Right now, primarily, we're working in plastics, so totally different vertical than machine metrics right now, but which is funny because it's such a huge space that you can have two different companies that are just both growing rapidly and don't even touch each other. And why do we exist is because I also have a slide with big numbers on it. There's $1.7 to $3.2 trillion, which is the projected impact on global GDP by 2031, just in manufacturing. So this is an enormous marketplace. There's an enormous, as was just said, there's an enormous place for us to grow into. There's, it's all for the taking. But I mean, really, what it really shows is how much inefficiency there is. Like, think of how much waste that is. Think of how much plastic is being thrown out. Think of how much is being just, burned away. Think of how much time is being wasted that we could be spending, at home or having like a better time with our families. Like, this is really, it's less about making this money. It's more about improving, the livelihood of this entire industry. So what is the product? So I'm going to give you I'm not going to give the sales pitch of the product because that is just not what I'm good at. I'm going to explain what I worry about, which is, how do I feed this product? So we have a real-time view of a factory. There are lines that are operating in that factory. There's states to those factories. And then there's products that are being produced on each one of those lines. And there's, some sort of aggregates about like what's currently happening, like what's the speed it's moving at. We have a time series view, which is, let me dig into my data from, T0 to T1 and try to actually analyze these metrics and see the state as it changes throughout different phases throughout this time. And we find this is really useful for people to go back and retroactively understand what happened if something was off, if something like isn't being produced at the same level. They don't have to go into, stats tools that were written in the 60s. They can use this. We also have a spreadsheet view. And this is an interesting view because it's actually aligning, so these are kind of like business concerns going down as rows. And then across are kind of like aggregates about those business concerns. So here you can see products that were being produced. And over here you can see what the average machine speed was when that product was being produced or what the total amount of products were produced during that time. And then we have reporting views where we send reports and tell someone, where should I focus my attention on today? As I enter in the day-to-day, what deserves my attention the most? So let's talk a little bit about data acquisition. So data acquisition is largely, this is theoretical, a little technical, but work with me. So data acquisition is largely done by, we have some devices that sit right next to PLCs and read from them. Right now we use Raspberry Pis. And we basically send requests to get data, get back metrics. and then enqueue that into a Redis queue, and then that gets propagated to disk. And then from that Redis queue, we constantly pop off and publish that into Google PubSub. So we're entirely on GCP, and this is basically our very simple diagram as to how we get data off of the actual device, how we get it off the machine, and feed it into the cloud. When it gets into the cloud, we break it up into a few different places. We fan out. We kind of have a hot or live kind of way of looking at it, which is using Google Bigtable, which is essentially key value store-esque. I'm sure someone from Bigtable would be very sad if I said that. There's BigQuery, which is much better for kind of slower analytics. And then we have Dataflow, which is actually used to do continuous roll-ups of the data. So as the data is flowing in real time, we can actually stream process it. This is using Apache Beam. I think this is similar to like streaming Spark, although I haven't played with that much. And that also feeds back in a Bigtable. And then both of these, and then the BigQuery stuff, we can ETL into Postgres and feed into this platform, which is what we actually feed to our customers. And so to the customer, they kind of have access to two different pieces of data. They have like the hot data, and then they have the slower data that's been computed. I think in the future, how we'll probably reorganize this is make it all downstream of each other. I'll get into exactly why in the future. But the idea is that the rough idea is, I think we want to make this chain of dependencies where we can confirm that our data is going to be consistent, as opposed to this previous strategy. You could imagine stuff in this fan-out phase gets inconsistent. And I think this is the kind of things you start to worry about when you're in this space for a funny reason, which is, as was brought up, manufacturing is kind of like a crazy space. There's a lot of noise. There's data that goes down. There's Wi-Fi that knocks out. This could be a factory in a place with only one ISP, and that ISP could not be that great. So I think accounting for that, like really thinking about our data and thinking about how we acquire it in a way that will, scale and keep working and be consistent is really, really, really important. So mapping the factory. So this is a pretty traditional trying to understand how someone's going to look at our data. So there's some metric right here, right? And this is Bob. And Bob wants to see some metric. And the question is Bob allowed to see this metric? And so Bob belongs to, some organization. And some organization owns multiple factories. And a factory has multiple lines. And a line has a device hooked up to it. And a device is hooked up to, or has a machine hooked up to it. And a machine is hooked up to a device. And the device feeds the metric. And this is a really complicated relationship, which you could easily model in some sort of relational database. Except there's also situations where maybe Bob belongs to a team, and the team only has access to one factory. Okay, it's still something we'd probably model in a relational database. But then you could also imagine another situation where now Bob is reporting to some sort of team that's responsible for just maintaining a machine in any factory. They could just only be worried about, some sort of ARM device in every single factory in the world. And we have to be able to model that permissions. And I think this is even more than just the idea of, how this is at a very high level how permissions work. But you can think of this as like, how do I think of how organizations interact with each other? How does one big conglomerate interact with a sub-conglomerate? How does one team have access to what another team is doing? And it's not simple. So you can see that we end up in this weird situation where all these have to exist side by side. And the solution there is that we end up using a graph database to model this. And it nicely separates out this entire relationship and lets us think about the factory in a very abstract way. So the factory is it's not about there being this weird hierarchy structure. It's more so that there are nodes, and we can make those nodes describe kind of how we interact as people and as businesses. So there's this interesting process I went through when I first started at the company, which was trying to define what our data was, because it's a lot of data that's coming in, and then we would build a bunch of dashboards and show it. But I think at the time it was, let's do this, and a lot of it was we kind of got together and we had a big conversation about what what does all of this mean? And I think a lot of it for me was a learning exercise to try and catch up. So when we think about our data, the first thing we think about is a metric. So a metric is an immutable floating point value that's reporting the state of some sort of process in manufacturing at some time. So this is very classic. I have a device, and the device is talking to this machine, and the machine is currently 10 degrees. And it reads that metric and feeds it up into space, all the way through space to us. And we end up reading that in at some time. And the thing that's nice to think about this way is that it never changes. We're never going to go back in time and say that that machine was a different temperature than it was. We know that's just what the state and the reality was at that time. An interesting thing about this is that we're not getting these data points consistently. This is a continuous process that we're trying to model. And instead what we end up with is individual bits tracking it at time 0, time 1, time 2, time 3, time 4. And this is actually kind of interesting. Like, this graph really does not capture the messiness of the data. What you actually end up with is a lot of points all over the place. And you run into these questions of like, what does this process look like? If I'm trying to decide whether or not this process at any time is exceeding some boundary, how can I do that effectively if I'm only sampling it once a second? And that's an interesting thing we play with, and it's one of those things you constantly have to keep in your head. The next kind of thing we think about is like intervals. So an interval is a span of time that maps to some sort of business concern. So what does that mean exactly? So I think an example I have is, line 13579 is producing lot 6 of product A10 from this time until this time. That's like a thing that happened on a factory floor. And what's interesting is it's not immutable. We think it's immutable because we're like, oh, we can't go back and change history. But if you actually have ever worked at a company, you find out that people go back and change history all the time. People need to go back and say that actually, no, it turns out it wasn't A10, it was A11. Or actually, I forgot to enter in what that was, and I was totally wrong the entire time. So this actually needs to be this is a mutable idea. One thing that we did define, though, is that you'd never have a line producing 2 products simultaneously. Basically, this allows us to say very discreetly what are the labels we can apply to the state of that process at this time in a way that we don't have to worry about overlap. We don't have to say that there's 2 products that both line up with this temperature. And it's interesting when you start to get into this because you start to get into these like many different types of intervals that you actually have to worry about. For example, was my process up or down? Were we actually producing something? What lot or what run or what reel, what batch of things was I making from some time to another? What type of product was it? And even then, these events might not come in the right order. And this is actually a problem that we've been fighting with internally. We're trying to figure out, like, wrap our heads around how do we resolve this? And I think the thing we're trying to figure out now is, like, can we create a hierarchy to this? So if we can create a hierarchy, we can say, this interval is a subinterval, this interval is a subinterval of this interval, and these are like how the business concerns lay out, then it works out nicer. We don't have this messiness. Whether or not we can do that, that's another question, but it's a challenge. The third type of thing that we worry about is aggregates. So what is an aggregate? So an aggregate is something like when the line produced lot 6 of product A10, 0.5% of the product produced was not within specification. So that's basically a high-level aggregate. That's a high-level statistical aggregate. That's some sort of high-level value, some sort of high-level number that we're assigning to a business concern. So something happened from time A to time B, and we now want to take all of these points of data, which if we were to look at directly is really hard to consume, and consolidate it down into something really, really strong that we can just deliver to the customer. And this is interesting because, as we said, an interval is mutable. We can change whether or not what product was running. So this is actually something that also can change, and it becomes this interesting problem for us to play with in our heads. How do we deal with this? And so this is the most general thing that I think a lot of people run into in just about any analytics space. Is I had some span of time, and I want to talk about it. An interesting problem you run into is how do I do this efficiently? Because to one respect, I don't want to necessarily read every single data point ever for the period of time that I'm talking about. If I want to talk about this over an entire year, I don't want to have to go back and read the 1 second times, I don't know how many seconds are in a year, a lot. There's a lot of seconds in a year, and I don't want to go back and find every single one of those and just to calculate an average. It's going to take a long time. So there's this idea that we've been playing with this this associative aggregate. And I don't know if you guys are math people. There's this idea in algebra called the associative property, which is formally defined as x star y times. What this really means is I can take one thing and add it to another, and then combine them, and then take another thing and add it to that. So an example of this would be addition. I can say 4 plus 5 is equal to 9, and I can add in 3, and that's the same as saying 4 plus 5 plus 3 is equal to the same thing. Examples where this falls apart is, I think the classic example is matrix multiplication. But you can imagine how this falls apart if you're trying to calculate, for example, standard deviation normally. Because you have to do 2 runs. You have to calculate a mean, then you have to calculate a standard, you have to calculate the variance. But separating out what is an aggregate versus what is an associative aggregate is useful, because if we can talk about things in terms of associative aggregates, then we don't have to go back and calculate a massive aggregate for the entire year. We can calculate an aggregate for one of every single day, and then only combine 365 of them. Some examples of these are like if you want to calculate the sum of some sort of value over a long period of time, or the count. Mean isn't associative by nature. If I had the mean of something on day 1 and the mean of something on day 2, you could take the mean of those 2 things, but you don't know how long the day was. Maybe one day was Sunday, and there was no one in the factory, or there was a shorter shift in the factory. Another example is mode. Another example is percent, which is similar to mean. A KS statistic. So this is if you're running like a KS test to check the normality of a bunch of data points. How much does this fit a normal distribution? A standard deviation normally is not associative. A rate, these kind of metrics that customers tend to care about, which talk about their quality or their, the process capability of CP, CPK, CPMK, CPM. Those are big things in manufacturing, and those don't fit in this kind of model that we're trying to work with. But through some fun math, you can actually reach a lot of these. There's actually a way you can redefine standard deviation to work as an associative metric, where you just talk about it in terms of sums and counts and sums of squares, as opposed to doing a 2-pass approach to it. I don't know if anyone's ever played with this, but when I saw this, I was actually really impressed. I came in having never seen it before, and it was new to me. So everyone who was there before me at this company really thought it out. And what's useful about this is if we go back to our problem of how do we think about these intervals? How do we think about things that are happening in the factory and how they relate to each other? Then we can get into this game where we start to think about associative aggregates and how they build up. So we don't necessarily have to talk about what was the average line speed for this product that was being produced over this period of time, when we can talk about the individual states that made up that product being produced over a period of time. And that allows us to do some really interesting things from the database level, where now we only have to compute these things on write, and we can compute these things on read. And what that allows us, how that fits into our kind of architecture now, is now we can talk about how we can have our similar kind of hot data system go down, where we have these individual data points are flying into Bigtable. And this is really useful for doing that kind of time series view of let me just query a bunch of metrics from time 0 to time 1. But for when we're trying to do these slower things, when we want to talk about more complicated things that relate to business intervals, to things that happened in the business, we can do them in advance using this kind of logic, where we compute it all here and then aggregate them all on this read process. So we can just do all of that here and then bring it into the read. And this is actually really important for this. This is how we are trying to get to solve this problem of how do you do a spreadsheet view? How do you map business to these numbers? It's a really challenging problem when you have a lot of data. And people ultimately want to be able to say things like, of all the products I produced, which one's doing the best? Which one of these is operating, which one of these did I produce the fastest? How fast can I produce it before it seems to become an issue with the quality? How fast can I produce it before it seems like we're getting outside of specification? So this is a really it's a helpful tool, but to get there takes a lot of work. And this is an example of how that kind of works out. And this is actually interesting because it's very similar to the kind of approach that, this is the kind of problem that timescale actually solves really well, is this idea that I have a bunch of business aggregates that I could define in relational databases where my business lives in terms of time series, and I want to join that against time series data. And then these are rough runtimes. Question?
Like, how many of these aggregates, do you split up your computations in terms of like batch jobs and then stuff you do in real time and combining those two?
Do we split up into batch jobs versus real time?
If you want to compute some aggregates and they take a long time to compute because you can't do them on write, you can run batch jobs and then kind of approximate the real answer.
Oh, you mean continuously approximate the answer as it's going? That is one approach you can go at it. That actually fits really well into the data flow model. But I think the problem is that ultimately your intervals are mutable because your business is mutable. Because you can always go back and say that something else happened. And so we always have to kind of reapproach. The important thing, like the thing that's interesting about the way the pipelines work is this is all immutable data, right? This is all like this is just like what was the state of my process at some time. And I'm just rolling it up in some sort of one way or another, and I'm feeding it into a system that can be read. This is a much more complicated problem because, again, like what we're ultimately computing in here is what are the things that happen in my business that I need to know about? And that just changes because we might tell someone that yesterday you really did really poorly, and then they realize that someone made a mistake at the level of entering it in when they were starting the process, or maybe they just were confused about what the product was. They have to be able to go back and relabel the data. So accounting for that is basically what we're trying to get at here. And then, what this argument is, anyone who's like also a runtime nerd, I'm pretty sure that most of the time when you're selecting from a database, you usually get it in O of log of n. The difference between here is if you were to naively compute try and get a bunch of aggregates of like k aggregates from a database, a time series database normally, you'd be k times log of n, right? Because you have to make a fetch for the n metrics k times. The difference here is when you're doing the pre-computed intervals, you get O of log of k times the number of data points that you're trying to catch. So you bring the k into the logarithmic, which is pretty cool. And I have a lot of math that argues that, if you guys want to talk to me later. So the next question is like, how do we be smart in manufacturing? So when I was brought into this job, kind of right away, people started talking about machine learning. And I think that is kind of the way that all IoT is evolving. Everyone because it's a hot buzzword and it seems like a really useful use case, right? Like I mean, part of it's a hot buzzword, but also because it solves a really unique problem. Because it's there's all these processes that are very human driven. And very human driven sometimes means that someone's going in every single day and printing out 100 pages of reports and then eyeballing a bunch of graphs and trying to figure out which one of these is off. And you're just eyeballing a bunch of graphs and you're like, how do you know which one of these is bad? And it's like, oh, well, years of looking at these graphs, I'm really good at eyeballing which one of these is bad and which one of these is good. And it's like, this is exactly what machine learning was made for. Like, you're just a machine right now. What if we just made your life better? And so a formal definition of machine learning, there's this definition from Tom Mitchell, which is like a computer program is said to learn from experience E with respect to some class of tasks T with performance measure P, with the performance of tasks T as measured by P performance with the experience of E, which is just excessive. It's a function with behavior that adapts over time. That is the way to think of machine learning. It's as we continue to use it, as we continue to feed it data, it adapts. It doesn't necessarily improve, but it adapts. It changes with the behavior. So there's this really great blog post on Hacker Noon that's like the AI hierarchy of needs. And this is basically all the things you need to work through to get to the point where you're actually doing AI. And I think this is something that a lot of people kind of just jump ahead and they don't realize that there's a lot of really human problems that are between, I just started a startup to I'm doing fancy machine learning, and then they fall and crash and burn. So the first problem is collecting the data, and this is actually really, really, really hard. And I'm really happy that we have people who are awesome who have figured this out because I never could. I only focus on the dumb problems. We then move to moving and storing the data. Can we reliably take this data from these sources where we're collecting it in IoT, which again is a really wild place. These are little devices that are spread all over the place that are pretty cheap and pretty faulty sometimes. And if they knock out, then we're going to lose that data. This part's not easy. Exploring and transforming that data. Can we just clean that data? Because a lot of the times it's going to be wrong. Sometimes things were misconfigured. Sometimes we need to go back and correct stuff. Aggregating and labeling that data, learning and optimizing that data. I think this is where it starts to get a little bit specific to, I think she might be in ad tech, I'm not sure. But it starts to get a little specific. But then as you work your way up, you start with the simple machine learning. You start with things like linear regressions and k-means, and then you work your way up to the deep neural nets. So there's a clear progression here, and I think people like to jump straight to the top. But there's an enormous amount of value if you can, as you start to get up over here. The question then is, where is that value? So where in a factory do we benefit from learning? So probably shouldn't learn. A metric, like I said, is an immutable thing. It's describing a state at some time. There's no reason that we need to bring machine learning to this. An interval, again, it's reflecting a business concern. Maybe I can take an argument that maybe there's certain interval classifications that you want to do automatically. But I think for the most part, business is business. We're not telling someone with our fancy machine learning algorithm that no, you're actually reproducing this other product today. They know their business. Associative aggregates, again, because these fall into this thing where we're depending on them in a hierarchy. So we don't want to break it down. We want that to be pretty consistent. And I think that's a big piece of it is we want consistency with these really, really fundamental things that we're giving to our users. Places that could benefit, though, is maybe there are some aggregates that are not associative that we just have to compute on the fly that we do with machine learning. Maybe there's configuration that we do with machine learning. Maybe we can identify that this is the way we think you should be running a process, or this is a way that this is a target we think you should be trying to meet without having to, and that's kind of a suggestion. It's like, hey, instead of you trying to come up with this idea just out of nowhere, let's take what we know and see if we can help you. And always give them the ability to, replace that. They're just suggestions. And then I think the most important thing is actually attention gating. So how should I, as a worker, most optimally spend my time today? And so this goes back to one of the pieces of our product, which is just we send you an email report in the morning, which says, hey, what happened yesterday? What do I need to focus my attention on? And I think this is a really fundamental thing because realistically, our attention is fleeting already. So I think this is a kind of thing where it's if we mess it up, if we don't only do it 95% right, it's okay because your attention's all over the place. The goal is to try and pull out pieces that you normally wouldn't see and bring your attention into it. And maybe we give you a false positive and you look at something and you're like, that's really actually totally fine, but I totally get why you thought it was bad. And so this is where I end up with what I believe is my manufacturing analytics hierarchy of trust, which is kind of my counter to the hierarchy of needs. And this is how do we work our way up to that? How do we bring value to the customer? And I think at the very bottom, we have to be able to confirm that the data matches what I as a user know is true. So if I as a user know that this temperature is always between 50 and 100 degrees, then if we tell you 10,000, clearly it's wrong. And I think it can't be overlooked because that is a big dependency. You have to do data acquisition well. You have to have clean data. You really have to think it out. The second layer is context, such as visualizations and aggregates are clearly supported by the data that I can explore. So we've given you a bunch of data that you now trust. Can we now tell you things? Can we give you a visualization? Can we give you a pie chart? Can we give you a number that is supported by that underlying data? And can you look at that and quickly understand what's happening without having to dig into the data itself? But always give you the ability to dig into that data and confirm that what we're saying is true. Is my attention being brought to the things that need it according to the context? So if we're bringing your attention to something, if we're sending you an alert, if we're sending you an email, we should be able to provide you context via an aggregate or some sort of pie chart or some sort of graph that says why do we think it's important that you look at this right now. And if you could do that, then that's huge. And then the very top of the pyramid is I can trust the system to tell me things that I don't intuitively know. And this is the great place to get to, right? Because the goal ultimately is not just to optimize a person's time, but to make them do their job better than they were to do before. Not just in less time, just like overall give them superpowers. People always talk about that, machine learning and AI are going to replace people, and it's never about replacing people. It's about we are bringing tools, like as analytics companies, we are bringing tools to, and through IoT especially, where it's the most in touch with us as people, we are bringing tools to people to give them powers they never had before, to give them X-ray vision, to give them, lightning fast responses. And I think as you work your way up this, you get to this beautiful thing, which is my time is spent on highest value work. I'm not wasting my time reading a bunch of, pieces, printouts that have a bunch of graphs and trying to eyeball which one's good or bad. I'm not wasting my time in, stats tools from the 60s. I'm not wasting my time anywhere. I'm just doing the thing that I need to do, that the baseline of my job is completed, and I can focus on making my business better. I can focus on improving. I can focus on being, bringing that $1.7 trillion of GDP to the world. And that's all I got. Questions? Yes.
When you were, and forgive me if I get some terms wrong, but when you were aggregating over time, did you choose the intervals ahead of time? Was it pre-aggregating over certain intervals, or can you query arbitrary intervals?
Yeah. So when you look at a time series view, I'm looking at like n number of metrics from T0 to T1. So that's a totally selected thing in second resolution. If I'm looking at, if I ask this, but there's this more abstract question that I could ask, which is, tell me my top products produced yesterday by how likely they were to be out of specification. That problem is more, we can say that was over yesterday, but the individual time ranges of each one of those is reflected in the interval itself. So the customer is setting that ultimately by entering through, we actually have a tablet interface and they can say, we are now and we also integrate with the machines, so we can say that we are now starting doing this versus doing this. So ultimately it's entered by the operators or by the process. And then they can also go back and edit it and we have to recompute these. Yes?
Will you be posting your slides someplace?
Maybe. We can chat after. Any other questions? Yes?
Attempt to create models of this large data sets that you have. For example, in an industrial setting, you have these parallel graphs and you end up quickly getting this data. Are you attempting to model the flow of the work that will produce the product that would be valuable to the
You see the advantage of the graph now. This is also where the graph kind of comes into so the question is, do we model this? For the flow. So to me, the flow is like, I can imagine a case where we are, say, producing cable, and you produce one bit of cable, you produce another piece of cable, and then you have to twist those two pieces of cable and produce a third piece of cable. So now you have to identify that if like the downstream cable has a problem, how do you identify that the upstream cable was the issue? And I think at that point, now you're talking about a directed acyclic graph. So that is, there is a flow to it that is modeled. It is in the pipelines. It's something that we're working on, but that is something we're trying to adapt for our customers, yes. And another question?
Is there a chance you could go back to like one of the first slides where you were quantifying the addition to GDP through efficiency?
I could tell you what it was. It was 1.7 to 3.2 trillion, and this was from a McKinsey article.
Except that what the text said under it was that from IoT.
From IoT, yes. Sorry, specific to, this is growth that is expected in manufacturing from IoT. I think the article came out in 2016 and it was projected for over the next 15 years, so to 2031.
The point is that what it's saying is that, is it saying that it's using, that the use of IoT will create efficiencies to add to GDP?
Yes, so the original article actually talked about what was the total GDP being added to the world by IoT in different industries, and then it broke down specifically what percentage of that would be manufacturing. And I think it called out manufacturing as the largest place to see growth from IoT, specifically. Yes? Any other questions?
IT is better than Google. Google doesn't have So the product at all.
Google doesn't have a competing product?
Google doesn't have.
Doesn't add GDP?
So yeah, doesn't have.
Well, I mean, they should get into IoT. They should get into
That's why I'm asking. Why is it better?
Why is what
Than
better?
Google.
Google? Then
Yeah,
Google?
Google doesn't have. Why do I care?
You have to choose.
Yeah, I don't. Do I have to choose between
They have NAS.
Google? Yeah.
They have servers.
It's economics. I don't know.
Autonomous is smaller than manufacturing.
Yes. 2 more questions. Yes.
So let's go a little in the weeds on here. What does your data preparation pipeline look like? Because scrubbing of data that's coming in there real time is a very, very hard problem to solve because you're going to need to convert from Fahrenheit to Celsius. Each instrument is going to record different errors in different formats, and trying to scrub real-time data is really, I mean, I work at Bloomberg. Trust me, we take millions and millions of data points per second.
I am going to say that the solution that we have is a fantastic forward deploy team who is far smarter than me. They go and they work with the actual, so we have members of our team that actually go out to do the integrations into factories and initially solve those issues of let's convert from imperial into metric. Let's get everything into this. Let's convert from scientific notation into a floating point number. So they approach those problems right off the bat there, and then immediately I kind of jumped over some pieces. We have an acquisition server in the space which rejects messages which are out of sync, and it doesn't actually initially reject it. Actually moves them to a separate queue to be reevaluated. So we try not to lose any data, but we also try not to let any bad data into the system. And this is actually a really big concern when you're using BigQuery, because BigQuery doesn't have delete, right? So this is actually one of the reasons why in the long term I see us moving to a model where we're putting BigQuery downstream of another database, and we fortify in that database, and we can always replay into BigQuery. But yes, it's a huge issue.
I was wondering what was upstream and downstream of BigQuery. Have you looked at Google Data Prep? It's a tool off of Trifacta.
Yes, yeah, I have looked at data prep. I think right now we're using the BigQuery streaming inserts, and that seems to be working pretty well. I think as our BigQuery strategy evolves, it might change. Right now we're looking at different ways that we could use. I mean, right now it's just the stuff that's moving from, we have basic, I have like Airflow set up, and we're doing pretty basic SQL ETL from BigQuery to temporary BigQuery tables, and then piping that into Postgres. And so that's our kind of pipeline, and then streaming at the top. Yes?
Do you make a distinction in your models and your processing between continuous and discrete data?
Between continuous and discrete data. So there is the difference between an event, as in something changed. So for example, we just started producing something, and this is the continuous state of a process. I think the vast majority of our metrics, there's actually something I stick up there. Metrics are basically always describing a continuous state, as opposed to an event, which is like something new has happened, is a discrete event which gets set up to us, and it is actually handled separately in the pipeline. And that ultimately ends up composing intervals.
Right. So, I mean, if you build an one item of something, right? That's an event. So this actually happening. It's a packet.
Yes.
As opposed to some continuous processing assembly.
Yes. Yeah. So I think there are other places. I think as of right now we haven't touched too much into it, but there are places where you can imagine this coming up. If you're thinking of like for example, there's already quality detection tools. So for example, if you're producing cable, there might be something running on a line to check to see if it sparks. And that is a discrete event. That kind of data we're figuring out how to fit into the pipeline, but we haven't actually totally solved that problem yet. But I do agree with you that it has to be handled separately. Yeah. I kept missing you.
I have another question. It's kind of on the opposite end of what you did, so maybe you can't think as well, but I'm curious about the data collection side, and with machine metrics, we heard that sometimes with older machines, they need
Yes.
sensors. How much of that do you have to do with
Yeah, so the question is how much do we have to, so on the data collection side, sometimes there are older machines and sometimes we can't do it with the pies?
I'm wondering if that's true with what you're doing.
We do have to, I can't speak as well to it. There's actually someone here who could, if you want to chat with them afterwards. But I can't speak as well to it. But we do have a variety of solutions to ultimately connect the old world to the new. Because we do, it's true that in manufacturing, you often run into machines that have been running for 30 years and are quite happy that way. And it's interfacing with that is tricky. Yes?
This is just a point of information. There's a company called Omnio.net, I believe. They're in Denmark. And they went through one of the accelerators recently, Techstars or something. There's 2 people that sit there and write device drivers for obsolete or very old industrial equipment. So if anybody is looking to, kind of try to interface with.
I would recommend them to the NYC Transportation Department for the subway system.
They're working on some elevators for me, but this is what they do. They sit there and they're building this library of device drivers for.
That's good to know.
We invited them to this data plan, but they're demos.
Yeah. Let's chat after. Anything else? Nope. All right. Thanks, guys.